What we're going to be doing in this lesson is having a look at a very simple problem, but what we're going to do is we're going to take this problem and we're going to create a working Java program based on just the information that we've been given. Also means we're going to have a bit of a revision on all the terminology that we use when we're building Java programs and see where that fits into the programming that we're going to do. So the example we're going to give you is for a car park. Really simple car park class. The rules are that a vehicle can enter the car park and vehicles can leave the car park, but at any time there will always be a record of how many cars are in the car park at that particular time. So before we move on, just take a minute, pause the video and have a think about what the instance variables and what the methods are for this particular program, just based on the information that you've been given. So pause the video, stop for a minute or two, jot those two down, and then come back and we'll have a look if you've got the same as what I've got. Okay, here's what I've got. It's a simplified UML diagram, but it contains all the elements. We've got the class name, which is car park. We have the single instance variable mnumCars that will store the number of cars we've got in the car park, and we've got two methods: car in for when a car enters the car park, and car out for when a car leaves the car park. This is a general overview of the structure of a Java class, and this is where you sort of start from. Everything that you write in terms of your code is encased in a single set of class brackets. The class in itself has to have a name. In our example, it'll be called car park, and then the elements inside the class go in three separate sections, but they have to go in this order. First of all will be your instance variables, then the constructor, and then the methods. We're going to visit each of those in turn just to make sure that we know what's going on in each of them. So your instance variable stores number of cars currently in your car park. The only data type that's realistic for it is an integer, and there's an example there of how we declare an integer in Java. Use the data type first. For in Java it's int for integer, and then the name of the instance variable, not forgetting you put the semicolon at the end. Generally what you would say is the instance variable for mnumCars is an int. The constructor is added straight after the instance variables. First line there, it says all classes should include a constructor. Doesn't necessarily mean that there has to be a constructor all the time. You can actually get away with not having a constructor. I don't recommend it, to be completely honest. What I would probably do is I would put a constructor in there even if you don't use it, because in the future you might find that you do need to use a constructor, in which case you've already got it in there and you can just add whatever you need in order to get its functionality. But always remember that constructors are methods which has the same name as the class itself, and predominantly we use it for initializing instance variables at the minute. We will be using it for other purposes later on. When we create an instance of our car park object, we're going to create an empty car park. So what we are going to do is create a car park initially with no cars in it. So our mnumCars instance will be initially set to 0, and we'll add that line of code into our constructor. And that's what it looks like so far. What we've got is our class. We have our mnumCars variable which has been initialized inside the constructor called car park, so it's the same name as the class itself, and we've set it to the value of 0. So the next bit is to think about the methods that go in. Now if you go back and have a look at the UML diagram, there were only 2 methods that we wanted to include. Now then remember that the methods are the only way that the user or the program itself can actually add any form of functionality to our working program. So what we've got the car in method, which allows us to demonstrate that the car has entered the car park, and it adds or increments 1 to the value of m numcars. And then we've got the car out method, which does the opposite. It allows us to process that a vehicle's actually left the car park, and it decreases the value of m numcars by 1. And there's the 2 methods in question. The car in basically adds 1, which is where the plus plus comes along, adds 1 onto the value of numcars. And then our car out method, which has the minus minus, which allows us to remove 1 from the value of numcars. Let's not forget that we've got to get into the habit of commenting our code, and it's a good practice right at the top of your programs to put some kind of a header in, and I always sort of like to put in sort of the author and some kind of versioning system, so at least you've got an idea of how many sort of increments or changes have been made as well. You can put comments anywhere through your program, but there's sort of some rules about commenting your code, because you can over comment your code. It can make life actually very difficult for someone reading your code, or even somebody marking an assignment that you've written if you put too much. You can put them where you like, they have no effect on the execution of the program, they don't even get output, but mainly put your comments in for your program header in areas which are particularly difficult to show the functionality. It's quite handy with assignments and things like that, where you can add these comments and it allows you to explain the purpose of a particularly complex piece of functionality. It's good to put a very quick comment before the start of each method to explain its purpose. And if you've got, for example, a complex data type, might be an array, might be a user-defined type or structure, and it might be that you can put a little comment before that as well. But don't over comment your code. And I know that sounds a bit daft, because we always say, you know, you should comment your code, but don't put so many comments in your code that it actually makes your program a lot harder to understand or read. You certainly don't need a comment for every line of your source code. It makes it almost impossible for somebody to read it and, you know, clearly understand it. So, you know, use your common sense a lot of the times and just put comments in as and how you feel to. But make sure that you've always got a header, make sure that you've always got complex variables or data structures commented, and make sure you've got a comment for every method. You'll make life a lot easier for someone who's either trying to read or, in my case, mark the programs that you've been that have been written. Just as a reminder, there are 2 types of comments. You've got inline comments and block comments. Inline comments just use the 2 forward slashes and allow you to put comments in straight after them. 2 examples there, one on an empty line and one after a line of code. The one after the line of code is ignored, only in this case, the assignment instruction will be read by the BlueJ compiler. And then you've got block comments. Block comments are there for multi-line comments. You don't need to put a single line that goes on forever and ever and ever. Put a block comment in, and again, the compiler ignores it. It's just there for somebody to read. So let's have a look at a car park demonstration. Okay, so we've downloaded the car park example from the VLE, and I've already opened it in BlueJ. If you're not sure about how to open your projects in BlueJ, then I suggest you go back and have a look at some of the previous videos. We've got our car park class. We'll have a look at it in the editor, and as you can see, just like in the PowerPoint slides, we've got our class definition, and everything relating to that class is inside those curly brackets. Might be a good idea that you include comments, as I've done here and here, to basically just give indicators for the start of the relevant sections. So you've got your instance variable section, your constructor, and it may be that you put a comment in for each of your methods, but there's nothing to stop you, for example, putting in a section to start off the methods, and then you can put a separate method in, or a method comment in after each one. It doesn't do any harm, and actually it just shows that everything's laid out properly. So again, we've got our instance variables declared, our mnum cars as an integer, our constructor, which is the same name as the class itself, and when we create an instance of a car park object, we initialize it to 0. If we call the car in method, we add 1 onto the value of mnum cars, and if we call car out, we take 1 away, the value of num cars. Notice I've actually done it the long-handed way. It doesn't actually make any difference. So you could do it the long way, which is mnum cars equals mnum cars plus 1, or you could just do it the way that I've shown you in the PowerPoint with plus plus. What I'll do for the demo is I'll actually do one shorthand method and one longhand method, just to prove that they both work anyway. So I've made some changes, so I'll go ahead and just do some quick compile, and there's no errors, and the indicator's told us that that's been saved as well. We'll talk about that in a sec. So we've got our object, our class. We're going to create an object from it called new car park, leave the default name, and we'll inspect it. So what we've got at this particular time is an instance of a car park from our class called car park 1, and there's only the instance variable mnum cars that we can inspect from it. So what I'm going to do is put a car in. That goes up by 1. Now that uses the shorthand method, so we'll call that a couple of times, and the value has obviously gone up. And then the long-handed method, which was car out, that still works because the number of cars in the car park has gone down. So that's a pretty straightforward example. Okay, so I mean, that was quite a short example, and the expectation is that you're not going to make very many mistakes when you create little programs like that. But we do need to make sure that the bigger that our programs get, we fully understand what we can do when errors take place, or we fully understand what BlueJ will do when errors take place. You are learning programming, and the best way to learn programming, I've always found, is that you get things wrong and you fix them. Surprisingly, that's called learning. And I always use the compile button in BlueJ to make sure that we check that there are no errors in the code that we produce. The compile button will check for what we call syntax errors. Now, syntax errors are basically you not following the grammar of the code. They're very easy types of mistakes to make. I mean, the most common one that a person will make will be not putting a semicolon at the end of a line of code. Another popular one is not putting the curly brackets in the right places. The compiler will always be able to find those errors for you. It will highlight the error. It certainly won't correct it. It's down to you to put that right. But one thing you do need to be aware of is that a lot of the time what happens is that the problem isn't always on the line where the error actually occurs. Sometimes you'll find that the error has taken place before the highlighted error has actually taken place. Sometimes what you'll have to do is search upwards if the error isn't particularly obvious. Again, I'm going to run a demo in a minute to try and show you that, but there is another type of error that you'll get as well, where the grammar or the syntax of the code is perfectly fine. It's just that the way that you've written the code means that it's not actually correct, and they're actually called semantic errors. Code with semantic errors may well compile, but you will only find that you've got a semantic error when you run the program and you get some rather unexpected results, and that's where you need to use your programming skills in order to identify those. There's a typical example of an error message that you might get. Again, it's one of the very common ones where you actually miss out a semicolon at the end of a line. You hit the compile button, and the first thing that BlueJ will do is it will give you an error message, and you're expected to correct that error before you can hit compile and your compile becomes successful. When it comes to saving your code, we have said in the past, and I will say it again, there's no file save option. There is no save button, so what you have to do is rely on BlueJ to automatically save your code. Now, there are two situations where code gets saved automatically. One is if you actually close down the code editor window, and it will save it then, and the other one will be if you hit the compile button. Now, the save indicator will, in both cases, will indicate whether the code has been changed or not. So you do have to sort of be quite careful. There's two examples that I've shown you here. In this example, there's actually nothing wrong with the code. You hit the compile button, and what will happen is that if there's no errors, it will say that there's no errors, but at the same time it will be saved. If you're in the code window and you make some changes, so you want to update it or improve it or change it because you got it wrong, the indicator will indicate that the code has changed but it's not saved. You will in that case either need to close the window down to save it or hit the compile button in order to save it. Either of those methods will do, but just be mindful that you will, if you change the code and then shut down BlueJ, there should be a save if you've closed down that window. If you just shut BlueJ down, you might not have that code saved, so just be mindful of that. If you have made some alterations and you want to actually get the older version back, and it does happen if you want to work it on something and you make a right mess of it, you want to get back to the previously saved version, you can go to class reload and you will lose all the changes, but you might get back to the version that you originally wanted. What will happen is you will get a prompt and it will say, you're basically going to lose all the changes you've made since you last saved. Are you really sure you want to reload it? Obviously, if you hit reload, you get the older version. If you cancel, you stay where you are. So let's go back to the car park example and let's just pull up a couple of errors and see what happens when we make changes or don't make changes in some cases. Okay, so we've gone back to the editor window for our car park example, and what we're going to do is we're just going to attempt to make some changes, and I'm going to show you how BlueJ highlights errors in code. Now, I'm actually working on the very latest version of BlueJ. You might not be working on that, but it works in a very similar way. So if there are any minor differences, it's probably because you're working on a slightly older version, although the error highlighting will still take place. So just to put you in a situation, I've just loaded up the car park example. It's uncompiled. I haven't made any changes to it, but what I'm going to do in the first stage is I'm just going to introduce an error. and I'm just going to remove that semicolon. Now if I click away, straight away there are two things that happen. One is that you will get some kind of a highlight that takes place, but also I've made a change. It's indicated that it's saved and there's an error. In the new version you do get an error indication. In the older versions, if you hit compile, it will give you an indicator that an error has taken place. Now this is a pretty straightforward error in that it tells me that there's a semicolon expected, and it has actually identified the line where the error has actually taken place. So for someone even only doing a couple of lectures in BlueJ, you can still identify where the error has taken place, and that's quite easily fixable. Straight away the error has been removed, but it only gives us a changed indicator. So the program has changed, it's not been saved. So what you've got to do is hit the compile button. The class has been compiled with no errors, and then it saves it. Now take into account that that's a pretty straightforward error. Let's take something a little bit more complex. So let's try and, for example, remove the curly bracket from the bottom of this method. Now you can see from the coloration of the methods and what's going on around there, there's something clearly not right. And straight away in this version it attempts to highlight where the errors take place. Again, you'll get something similar in the older versions as well, but it tells us that 4 errors have actually taken place. Now this can be a bit misleading in some respects, because you'll look at that and think there's something really gone wrong, and some of the errors aren't particularly well described. So sometimes what you'll have to do is look at where some of these errors have taken place and work your way upwards through the code to identify where things have gone wrong. So we'll take a look at, for example, where these highlighted areas are. We've got got things like semicolon expected. Well, you don't have semicolons at the end of method descriptors, so clearly there's something that's okay. If you look at some of that seems fine. The highlighting and the code alignment of the brackets should tell you that things are going right, but you do have to sort of work your way upwards sometimes in order to find certain errors. Now obviously we've got an open bracket for this method, and the compiler, what it's actually doing is thinking that this stuff, for example this method declaration, is actually a line of code from inside this method, and clearly it's not. What's missing is that we've obviously got a closed bracket that's missing from there. So what we need to do is obviously just add that back in, and straight away it corrects everything. So again, you've probably had lectures in the past where you've been told time and time again about your code layout, and a lot of these tools now include automatic code indentation, and it's there for a reason. It's there to make sure that you make everything as readable as humanly possible for the people who are going to look at your work or make changes to your work, or even people like me who are going to mark your work. And if you don't make it readable, it's going to make life a bit difficult. So use these error highlighting tools to find your errors, and let the tools where possible control your highlighting and control your code layout, because what they will do is allow you to sort of produce well formed code, which is going to be a lot easier for other people to read, and in some cases like me to mark. Okay, so let's go back, way back to probably the first or second lecture, and think about the shapes example. And in that particular example we had multiple object classes for our different shapes. We had circles and squares and triangles, and I think part of the tutorials that you had to complete was that you had to sort of make your own drawing as well. So you should be sort of well experienced now in knowing that you can create multiple instances of the same object, like in this example where we've got 2 yellow squares and another square for the door. So the multiple instances of square objects plus the house itself is a square. And you should be sort of well experienced in knowing about object properties or instance variables and how they can change by moving them or changing the colour of an object, and calling methods. And we can call methods for each independent object. And as you can see from the diagram, we've used BlueJ in this particular case to create about 6 different shapes or 6 different objects. So again, you're already sort of in the mode where you can create multiple objects from, in this case, 3 different classes. And we can inspect each of these objects individually, and when we call the methods in order to change them, we can actually inspect how each of the values alters as we go along. And we can do that with the car park class. We can create multiple car park objects. For example, if we're a large company with several car parks that we own, we can actually model how those car parks all operate independently within the same program, and we would call the car in and car out methods for each of our car parks, and we can view the object inspectors for each car park to see how we're getting on. And we'll have a look at that right now. Okay, so we've got the car park program open. We've already pre-compiled it because there's no grey lines on there, and all we're going to do is just create 3 car parks. We'll have car park 1, car park 2 and car park 3, and for each of those car parks we will inspect them. So we'll leave them up there. 1 and 2 and 3. And what we can do at this point in time now is call a method depending on whether a vehicle enters or leaves each of those car parks. So for example, we can have a car that goes in to car park 1, a car that goes into car park 3, and another one in car park 3. As you can see, that changes there. And then the car in car park 1 leaves, and again we call the method for that particular object, and a car goes into car park 2. So just to finish off, if we have a look at what we've looked at today, we've had a bit of a review of the content of a class, and in the order that it should be written in the class. We've looked at our instance variables, we've done a review of a constructor, and we've done a review of the methods. We've looked at some good practice elements for code commenting, whether that's single line or inline comments or multi-line or block comments. And we've looked at how BlueJ works in terms of when it saves the code. That's when you hit the compile button or when you actually shut the code editor down. We've had a little look at how syntax errors are dealt with, and given a little bit of advice on how to look for errors in your code. And then we finished off by creating multiple objects from the same class and inspecting them with the object inspector, and then seeing how we can make changes to the instance variables of multiple objects in the same program.